Hi everyone, this is a video on contingency tables. Contingency tables are used to cross-classify two categorical variables. Here you can see that we've got a contingency table on the number of concussions among university athletes by type of sport for the period from 1997 to 1999. The important thing about using contingency tables is knowing which cells to look at. For example, what proportion of people who sustained a concussion in that period did so playing soccer? To answer this question, we're going to need to get two numbers from the table. First of all, the number of people who sustained a concussion. And secondly, the number of people who got a concussion while playing soccer. Now we divide the smaller number by the bigger number to get a proportion, and that will be the proportion of people who were playing soccer when they sustained a concussion. This gives us 0.46. Here's another example. What proportion of people who did not sustain a concussion were playing basketball? Again, we're going to need to get two numbers from the table to answer this question. Firstly, the total number of people who did not sustain a concussion. Secondly, we need the number of people who played basketball and did not sustain a concussion. Now we divide the smaller number by the bigger number to get a proportion. This will be the proportion of people who were playing basketball when they did not sustain a concussion. So that gives us 0.26. Finally, it's important to be aware that different types of proportions can be calculated from a contingency table. The right way of displaying the data depends on the question we're trying to answer and which variable is in the columns and the rows. So here we've got the same data again, and then in the middle table we've got the same data but in proportions of each column. So this means that each column adds up to 1. This would be useful if we wanted to know which sport has the highest proportion of players that sustain concussions, because it allows us to compare different sample sizes. For example, we've got 100 people who sustained a concussion while they were playing softball or baseball. This seems like quite a high number, and obviously it's more than the 77 people who sustained a concussion playing lacrosse. But because the total number of people playing each sport differs, these numbers don't mean so much by themselves. When we calculate the proportion of each column, we can see that actually a higher number of people get a concussion when they're playing lacrosse than when they're playing softball or baseball. We can also calculate the proportion of each cell, as we've done in this bottom table down here. This means that the entire table adds up to 1. This is less common, but we could do this if we wanted to know what proportion of university athletes played soccer and didn't sustain a concussion, for example.